Basics. Right. Do I need to have a recording telling you to put your laptop away again? Okay, let's go with differentiating this. What is my first term?
15x squared.
15x to the power of 4, right? Bring the coefficient down, so the power to multiply the coefficient and reduce by 1.
Minus 12x squared.
Minus 12x squared.
14x.
Plus 14x.
14.
Plus 14.
Plus
Then what?
0. Plus 0. Plus 0. Plus 0.
Okay, there's just nothing. I mean, I could write plus 0, but what's the point? Doesn't mean anything, right? So this is my differentiated term. All right, we are going to look at something today that requires something called the chain rule.
Oh.
So there were a couple of questions yesterday I told you couldn't do. For some reason, they were in 7A, but they require the chain rule and they differentiate differently. So if I have something like, so this is where we sort of start combining this with the binomial expansion, which you're all going to be very excited about. Ew. All right. So if I have something like that, what is your instinct in terms of differentiation? So if I wanted to differentiate this, think about what you might do traditionally in the method we just...
Expand.
No, let's not expand. What do you think, Josiah?
I divide 8 into 7.
What?
Okay, so 8 comes down at the front, and then I reduce the power by 1. That's a really good guess, but it's wrong because of the chain rule. This is not wrong, it's just incomplete. What I also have to do is multiply this by the derivative of the brackets.
What?
So what is the derivative of this part? It's just 4, right? Because if I have 4x plus 5 and I derive that, I just get 4 and then this disappears. So when I do the derivative of something that looks like this, where there are multiple terms in a bracket with a power like the binomial expansion, what I need to do is do exactly what Josiah suggested, bring the power down and multiply out the front, reduce the power by 1, but the extra step is multiplying by the derivative of the brackets. So then 8 times 4 is? 32. So actually it's 32 4x plus 5 to the power of 7. Okay, so it's not that difficult, but you just have to remember to do that one little extra step. All right, let's do another example of that. So if y equals 3x minus 4 to the power of 10, I would like you to have a go at writing the derivative of this. If you don't have a book open a book. Yeah?
If you want to keep increasing the power, we need to keep multiplying by 4 and like putting 4 at the end of the
I'm not sure what you mean by keep increasing the power.
Like if you want to go, if you want to do like the power of 6 instead of 7.
I hate you. That felt like a long setup to a bad joke, but I thought that was by accident.
Multiply 7 to 32. And
Do you mean if you wanted to do a second derivative?
Yeah.
Yes, you would. We're going to talk about second derivatives later. We're not doing them at the moment, but yes, that is what you would do. All right, so if you have not opened your book and done this as a derivative, please do that now. So practice using the chain rule.
Good.
All right, not everyone is holding a pen and writing, and you should be. I want you to derive this for me. Hang on a second, I want to see everyone have a go at this first. All right, so we're going to do our normal derivative and then use the chain rule.
Is that a 10 or is that a?
That's a 10, yes.
10 or is that I did
That.
Oh my goodness. Jeez. Okay, so what would I write first?
Third.
Okay, let's not do that yet. I want to do it in stages. So what am I going to put first out the front? 10, right? I bring the power down. And then what have I've still got my bracket. So what's my new power? And then what do I have to do? Multiply by 3, because that is the derivative of the bracket. So like Hans said, I then have 30. 3x minus 4 all to the power of 9. All right, let's start to make it slightly more complicated. Not particularly yet, but let's have another term out the front this time. So I'm going to have a 2 out the front this time. 2x to the power of 5. I've now got a power inside my bracket as well. Oh, it is actually, isn't it? All right, let me write that in a darker color. All right, so y is going to equal 2, 2x to the power of 5 minus 1 all cubed. All right, using, that is very charming, using the same chain rule. This is exactly the same rule, but it's just going to be a little more complicated because we have 2 extra things going on. See if you can have a go at deriving that for me. This one up here, the purple one. All right. So the derivative of this, it's exactly the same way that we just did the other two. There's just a couple of extra things going on, but you should be able to do it.
Is that 2x to the power of 5?
Yes. Adiel, you may need to go to an optometrist. You and Destiny can go and hang out at the optometrist together. I want to see you guys come back with glasses next week.
But I could.
Oh, you actually have, you have glasses?
Yeah.
You never wear them. Maybe you should wear them.
Sunglasses.
Oh. Is that better? Oh my gosh, Destiny, get some glasses. Jeez. All right. What do you think I need to do first? What's the first thing I write down? 6. Good, because the 3 multiplies by the 2 and I get 6. Then I have my 2x to the power of 5 minus 1. What's my new power? 2, because I reduce it by 1. Then what happens here? What is the derivative of these brackets? Good, 10x to the power of 4. This disappears, but that matters. Now this is going to multiply this. So what do I get? 60x to the power of 4, and then my brackets are 2x to the power of 5 minus 1, all squared. All right, we getting the hang of this? No? All right, I'm going to make it worse.
I said no.
All right, let's do it. Let's do another one. Okay, this time I'm going to say that y is 5 over 2x to the power of 4 plus 3 all to the power of 6. What should my first step be?
-6.
Good, we're going to make it a negative power. Just like yesterday, we don't differentiate when we've got fractions. So this is now 5 times 2x to the 4 plus 3 all to the power of -6. Now I can do my derivative. Okay, so exactly what we just did. Bring the power down. So what do I get? -30, because it's -6 times 5. My brackets haven't changed. What's my new power? -7. And then what do I multiply by? Chain rule? 8x cubed. Good, because that is the differentiation of this. All right, so because in the same way, so I just want to point out that, remember, if you have this, that is not x squared plus y squared, is it? Right? This is an open bracket FOIL situation, yeah? In the same way that this, you cannot just treat this like a single term. The chain rule exists to try and counteract this idea. Because you, remember, when you open this up, actually, you should have x squared plus 2xy plus y squared. See how you have a mystery middle term? That's kind of what this is, like the mystery middle term that you can't just put that on both things. Okay, so that's why we use the chain rule. I'm going to get rid of that just because it's now not helping us. All right, so now let's make this a little simpler. Let's put it all together. So if I, why have I lost the ability to write? What? What? Give me the, I don't want a highlighter. I want the pen. Ah, there we go. Okay. So if I bring this across and multiply it, what becomes out the front? Good, minus 240x cubed. And then I still have my 2x to the 4 plus 3, all to the power of negative 7. Am I done?
No.
No. What do I need to do?
It's
It's not information.
not.
What? Make it into a fraction so it goes on the bottom of the
No.
fraction.
They have to be decimal.
I hate you. Negative 240x cubed. And then, yes, it is. Plus 3,
Nice,
all to the power of 7. I'll show you not nice in a minute.